So hi ma'am, today we are going to break down this logic circuit step by step. So we'll start with the input, trace the signals through each gate, at the end with this final output. So let's get started. So first, let's look to the our input. So we have a x, y, and z. So the x is equal to 1, then y is equal to 0, then z is equal to 1. So notice that X, Y, and Z each go through a NOT gate, also a code of inventor. A NOT gate simply flips the signals, so if we input a 0, we get a 1, and if we input a 1, we get a 0. So coming out of this NOT gate, X is become which is 1, and y is become which is 0, and z becomes which is 1. So now let's level the let's level this intermediate points, the output of the first NOT gate. So we will draw a NOT gate, which is the x. We will draw a NOT gate. Then y is 0, then z is 1, then so first is a NOT gate. So from x is a, which is equal to 0. So the output of the second NOT gate is b equal to 0, and the output of the third NOT gate, which is the c, is equal to 0. So next is we have a NOT gate. A NOR gate is like an OR gate. So with a NOT gate at the end, it output a 1 only if both inputs are 0. If either input is a 1, the output is 0. So the first NOR gate, we will draw a first NOR gate, which is we will draw so the first NOR gate is the first NOR gate takes A, which is a 0, and Y, which is a 0, as input. Since both are 0, the output of D is 1. The output of D is 0. So D is equal to 0. So the second NOR gate takes B, which is 1, which is 0. So we will draw a NOR gate here. So the second NOR gate takes B, which is 1, and Z, which is 1, the B, which is 0, the Z, which is 1, and as input, since B is 0, the output of E is 1. So the output of E equals to 1. So now let's move on the AND gates. So an AND gates is here. We will draw the AND gates here. Then here. So the first move on the AND gates. So an AND gates output is 1 only if both its input are 1. If either input is 0, the output is 0. So the first AND gate takes D, which is 0, and E, which is 1. As the input, since E is 1, the output is 0. So the F is equal to 0. So the second AND gate, so this is the AND gate. So the second AND gate takes F, which is 0, and which is 0 and Z as input, since if NF is equal to 0, the output of G is 0. So finally, the second AND gates, so after tracing through the entire circuit, our final output is G is equal to 0. So now we move to the number 2. So first, let's look at our output. So X is equal to 1, then Y is equal to 0, then Z is equal to 1. So notice that X, Y, and Z each goes to a NOT gate, also called an inverter. As we know, a NOT gate is simply flip the signal. So if we input a 1, we get a 1, we get a 0, and if we input a 0, we get a 1. So let's label this intermediate points. The output of the first NOT gate from X is a 1. From so the first NOT gate, we draw a X equals to 1. This is a NOT gate. So we draw a NOT gate from X which is a 1. Then Y is 0. Then Z is 1. So the output of the first NOT gate from X is equal from X, which is from X is A equal to 0, and the output of the second NOT gate, which is the Y is 0, the output of B is equal to 0. Then the third NOT gate is from the Z, so and C is equal to 0. So next is we have an AND gate. An AND gate is the output of 1 only if both of its output are 1. Its either input is 0, the output is 0. So this AND gate takes, so we will do an AND gate here. This is a AND gate. So the AND gate takes A, which is 0, and B, which is 0. As input of A is 0, next is we have an AND gate, so the both of only, so the E, so the output of D is 0. So the second NOT gate is belong to a second NOT AND gate. Which is the so which is the so bit takes A, which is a 0, then B, which is a 1 as input of, since the input of A is 0, the output of A is 0. So now let's move on the OR gate. An OR gate, the output is 1 if either of its input is 1, if only output a 0 if both input are 0. So we will draw an OR gate. So our OR gate takes A, which is a 0, then C, which is a 0. So as input, since both are 0, the output of D is 0. Di ba no? The output of D is equal to 0. So now let's move in an OR gate. An OR gate, like an OR gate which is not gate at the end. Its output is 1, only both inputs are 0. If either input is 1, the output is 0. So this NOR gate takes D, which is 0, then E, which is 0. As input, since both are 0, the F is 1. Is equal to 1. So now let's move to the NOT gate. So we will draw here. So the simple flips of the signal. So if we input a 1, we get a 0, and if we input a 0, we get a 1. So this NOT gate is F, which is a 1 as input. So the G is equal to 0. So let's move to the NOR gate. A NOR gate is like OR. So the gate with not a gate at the end. If output is 1, only if both inputs are 0. If either input is 1, the output is 0. So we will draw a NOR gate. So this NOR gate is take a C, which is a 0, then G, which is a 0. As input, since both are 0, the H is 1. The H is equal to 1. So finally, we have a NOT gate. A NOT gate simply flips signals. If we input a 1, we get a 0. And if we input the 0, we get a 1. So this NOT gate, H which is a 1 as input, so output is 0. The output is 1, I is 1 is 0. So after tracing through the entire circuit, our final output is, it's either a 1 or a 0. This is a 0. Output 1 is 0. And that's all. We have successfully worked the logic circuit and determined the output based on the given output. So thanks for watching. That's all.